Will I be interrupted? Be interrupted again by an announcement coming on the PAs, my friend. So we're looking at electric potential, example number 4. And in this problem, we are asked, what is the velocity of an electron with a kinetic energy of 750 electron volts? And it's important for us to remember that this 750 eV here, that is an energy. We can think about it as stored potential energy if we are in an electric field, or if we have a moving object, it could be a kinetic energy. It's just some amount of energy there. And if we're looking for a velocity from that, we have to go back to last year when we looked at ideas of mechanics and saying that 1/2 mv squared equals your kinetic energy. And because of this, we know some things here. We can say there's our kinetic energy, there's the velocity we're looking for, and we know the mass of an electron. That's some value we could look up on a table. And if we're looking for our velocity here, let's just solve this for v. Let's not put any numbers in. Let's just solve it for v real quick. So we'll multiply each side by 2, and then we'll divide each side by m, and then take the square root of each side. So we're going to get v is equal to the square root of 2 times the kinetic energy divided by the mass of an electron. Now, something we need to be a little bit careful about here is that this kinetic energy, some of us might have the idea that, oh, we'll put in 750 electron volts, but that's not in SI units. SI units are joules for energy. We need to convert that 750 EVs into joules. And it's important to remember that there's 1.6 times 10 to the minus 19th joules in every 1 electron volt. So we're going to have to make that conversion there, and then we're going to have to put in the mass of the electron. So the way we do this is there's our square root, there's 2 times, and here's our conversion right here. Our conversion is going to be the 750 EVs multiplied by 1.6 times 10 to the minus 19 joules, and that's per electron volt, and that's why these electron volts will go away, which is very nice for us. We're back to joules. And then we divide that by the mass of the electron, which is 9.11 times 10 to the negative 31 kilograms. And make sure all of that is in the radical. And boom, we're done. We run that through our trusted calculator we've had since the year 2006, and we find out our velocity here is 1.6 times 10 to the 7th meters per second. And that is very, very, very fast. It's not as fast as the speed of light, but we're only a factor of 10 away from it. And with that, this problem is finished. Take it easy.